our university and what opportunities it gives to study in MEPhI and how to get a scholarship and something about our educational programs, our history, some facts. Just our university actually a network university that consists of 16 branches, which are scattered of the Russian Federation. Russia is a big country, and our university presented in these towns in Russia. We have a branch in Siberia, in the Ural Mountains, some campuses. But of course, the main campus is located in Moscow, and the second largest is located in Obninsk, which is about 100 kilometers from Moscow. It's 2 hours drive. Our university was established in 1942, mostly to prepare specialists for a so-called Soviet atomic project. We know that Americans first produced the atomic bomb, and in response to this Manhattan American project, the same project was launched in the Soviet Union. The preparation of staff for this project was a necessary task, and that is why our university was established to train specialists. And we can see that famous scientists participated in this activity, and we are really proud that they participated in the creation of our university. For example, you can see Professor Basov, who invented laser technology in 1962, I think. And for this invention, he was awarded Nobel Prize in Physics, and other some famous scientists. Also, we have 2 branches abroad, which were established 4 and 1 year ago in Uzbekistan and Kazakhstan, former Soviet republics. Now they're independent countries, quite big, and want to develop their nuclear infrastructure. For example, in Uzbekistan, they're considering to construct a nuclear power plant. And of course, 2 campuses, Obninsk and Moscow, the main 2 campuses to train specialists, were the biggest one, and all international students who come to Russia, to MEPhI, they study at these places, Moscow and Obninsk. A little bit about, it's a little unclear, the map, and in blue are shown countries. Actually, this is a picture, I think, is 3 or 4 years old. Now this number is bigger, and here you can see South America, and of course Bolivia. Just, if I'm correct, about 20 students from Bolivia studied in MEPhI, and in order to work in this new nuclear center, which is under construction in an Alto. In total, we have students from many countries in the world, about 80 countries. Of course, the majority of these students comes from countries which are developing their nuclear infrastructure. For example, Turkey, Egypt, Bangladesh, some African countries, for example, Rwanda, are considering to build the similar center within your country. And in total, we have, if we summarize all campuses, we have about 20,000 students, and 6,000 students are studying in Moscow, and about 3,000 students are studying in Obninsk. And if we take these two campuses, we have more than about 1,500 international students. So the ratio is pretty high. Here, educational areas where preparing staff not only in nuclear research and engineering, but in other areas, for example, plasma technologies, nanotechnologies, biomedicine, information technology, cybersecurity. In total, in MEPhI, we can offer more than 60 education programs in master, bachelor, and PhD degrees, and in 2 languages, in Russian and in English. Yeah, that's unreadable. That slide just shows you the growth rankings where rate some universities where their positions in some areas, and in total for several of these rankings. One of them is TG, also have Shanghai rating, and in these ratings, I would like to tell you that MEPhI sits pretty comfortably and is considered one of the best universities in the world, top 100 universities in the world, specifically in physics, specifically physics of nuclear engineering and astronomy, high energy physics, all these topics related to dealing with nuclear physics. In Russia, MEPhI usually we have some national rankings, and MEPhI is usually in top 5, top 3 in all Russian universities. It depends on the ranking and the area, but in general, the top 5 universities in Russia. Here, the structure of our university, we have now, this is the Moscow campus, and some Obninsk departments also contribute to these institutes. In total, we have 5 institutes specializing in different areas. The first one, the biggest, where I work and my colleague work, is called Institute for Nuclear Physics and Engineering. It's mostly, as you can deduce from the name of this institute, it is focused on training staff for nuclear power industry and fundamental research in particle physics. And about this institute, I will give you more information in my next slides. The second institute is called Laplace. This institute is about lasers and plasma, for example, thermonuclear reactors and projects related to nuclear fusion. The third one institute is BIO. This is institute specializes in nuclear medicine, also field related to nuclear technologies. The fourth institute, called Institute for Nanoelectronics and spintronics and photonics, and this is about development of new solid-state materials which can be applied in electronics, including creation of new heterostructural materials, which can be used in different other fields. And the fifth one, which is popular also because this institute is Information Technology Institute and trains specialists in the fields of cybersecurity and artificial intelligence. This is the numbers showing how many faculty members the students will have. Around figure varies from year to year. This is from last year. And at Institute of Physics and Engineering, we have about 1,700 students studying. Educational programs, you can see all the educational programs. This is master's degree programs. I think the majority of you use exactly them because we are all students, and you can see that studying in Russia after getting a bachelor's degree in Bolivia, you can consider joining some of these master's degree programs in physics, in nuclear power engineering, in plasma. This is programs which are taught in English. This is PhD programs and master's programs which are taught in Russian language. There are more programs in Russian than English. And in order to study Russian, you have to study Russian language, of course. And if you get a scholarship, you can study for 1 year the Russian language in order to start this program in Russian. Some master's program in Russian is in addition to the ones which I already mentioned, for example, material science, also electronics, software engineering, some programs in computer sciences. And from general slides, I would like to show you some information about our institute, Institute of Nuclear Physics and Engineering, where I work and do my research in the field of neutrino physics. This is a picture from my lab, by the way. And our institute consists of 3 main centers. The first one is about fundamental research in particle physics. This is the last slide of my presentation, which I showed today. Physics, which is trying to understand nature and how the universe developed, while we have so many different particles, how they interact, and to understand properties of these particles. The second center is specializing in nuclear systems and materials. And the third one is about atomic energy, nuclear power. And as you can see, in reality, all these 3 directions, they interact at some point. And that is why it's a multidisciplinary research. Couple of words about master English programs. We have in total 8 master degree programs which are taught in English here at the campus. Some of them in Orbit, some of them in Russia or in Moscow. And these programs are about nuclear power engineering, nuclear physics, and material science. And I will give you some details about the curriculum of these programs. We have these programs are 2 years long. Credit value is 120 ECTS, the standard value of language of instruction is English, and degree is Master of Science. The first program, actually, there are 2 programs. They have similar disciplines. They are very close to each other: nuclear engineering and nuclear power engineering. And on this programs, all students study all aspects related to neutronics, thermophysics, nuclear reactor physics, and they try to understand, get new knowledge in the fields of nuclear physics and develop new ways to improve if you want, and search for new ways to exploit the neutrons in nuclear reactors. Key disciplines, you can see them here. Of course, nuclear physics, nuclear reactor physics, nuclear transport theory, neutron transport theory, some courses on nuclear knowledge management, of course, some courses related to material science, about nuclear fuel cycle, and radiation protection. And of course, thesis preparation, which is basically done on the campus with the assistance of the three professors. Here are some areas of research where you can do your diploma. This is main directions: research on radiation transport, research on neutron physical processes which happen in the nuclear reactor core, how neutrons interact, how neutrons move, and of course technologies of closed nuclear fuel cycle, the future of all nuclear industry, and in Russia, where I would say pioneers of this technology and have a nuclear power plant which uses fast neutron reactors in Russia. And here we have a research reactor on the campus. We have nuclear power plant simulation labs when you can be some sort of operator of a nuclear facility using modern software. And of course, we also develop virtual reality simulators in nuclear energy, which can mimic actual experimental facilities. And we develop, for example, some critical assembly to use it as a laboratory work for our students. The second course, the second program, is devoted to materials. It's called Materials for Nuclear Education or Materials Design and Engineering. Also, we have all these English medium programs, the same, very similar programs in Russian language, because I'm focused only on English programs, but in reality, the variety of programs in Russia is greater, but the disciplines are very similar. The same things and courses, of course, nuclear physics, but if we talk about materials for nuclear application, we should understand that we have to study solid state physics, physics of materials, and how different conditions like high radiation, high temperature influence on the properties of materials, and why it's important to improve the core quality of these materials and how we can apply them not only in the industry but in other fields, including avionics, for example, or car industry. And here courses, some courses are about nuclear physics, and some courses are about materials and structure of materials, and how we can use these materials in different applications which require to work in harsh conditions. Here, that's some pictures from the Palazzo Materials Science Department. Areas of research: nuclear fuel, different properties of nuclear fuel, different techniques which are used to modify the properties of these materials, and the lab equipment which can test these hypotheses and can be used for future facilities. And the last program I would like to tell a little bit, this program is focused mainly on high energy physics, physics of accelerators and astrophysics, where we study properties of new particles, properties of cosmic rays, properties of neutrinos, for example. And this program covers all aspects related to theoretical physics. We should understand why we are looking for something new in the field of physics, and some courses which are dealt with modern data analysis frameworks, and some experimental courses which learn you to how to work with state-of-the-art equipment used in modern experiments. For example, just to have the same course, radiation detectors in nuclear physics experiments, which is a little broader than mine, but the main idea is to teach students how to apply different detector technologies in modern experimental physics. Here, experiments where we participate. Some experiments are broad, for example, CERN in Europe, some collaborations. Now, a big collider, which is called MEPhI, is under construction in Russia, which in the city of Dubna. This is city which is located about 100 kilometers from Moscow, at the same distance as Obninsk, but in the opposite direction, actually. This is a famous international center, which is called Joint Institute for Nuclear Research. And we participate in several experiments, which are, some of them are on the way, some of them are planning to be held here. And our students participate in this facility. Some experiments studying cosmic rays, like you, your colleagues from the Arais Cosmica lab. Some experiments we have also a cosmic rays related facility right on the campus, which is called MEPhI. And this facility studies cosmic muons, their property, to understand the so-called muon puzzle, the excess of the muons in the high energy range. Also, we have some international experiments, joint experiments with colleagues from different countries, for example, studying cosmic rays also on satellites. So we have a large and new cosmic rays observatory, which is under construction in Siberia in Russia, which is called, and this experiment is called Taiga. Actually, a big territory which is covered with detectors to study gamma rays and other particles. We participate in more than 30 international collaborations in high-energy physics, in feeder physics, in research in dark matter, in fields which include development of new setups and simulation and analysis of data produced in different centers, and of course R&D projects. Our partners, of course, here in the list of Russian companies mostly, but the main company who employs our graduates is the Rosatom State Corporation. Also, we have some commercial companies, some banks, but mostly for IT specialists. We have a strong collaboration with the International Atomic Energy Agency, and of course, a research center in institutions abroad, like CERN, and in Russia, Joint Institute for Nuclear Research, Institute of the Russian Academy of Science, and one of the leading institutions in Russia, also the National Research Center, Chartered Institute. We provide training for all our international students who study in the fields of nuclear technologies. We have 3 so-called resource centers, which are very close to real nuclear facilities, like nuclear power plants, for example. We have branches in these small towns, like Volgodonsk or Voronezh, and there are several facilities like Atamaj, where they produce these vessels, stainless steel vessels, where all nuclear fuel is located. This is the nuclear reactor vessel. And this training is about 2 weeks, and all students have the opportunity for this hands-on experience and try yourself to the real labs. We hold conferences in schools or in the different fields. Some of them are in August, some of them in Moscow, on different aspects of nuclear technologies. And if you want, you can participate in them online, just to get the knowledge. The dormitory, just some general slides about our university. We have the dorm. You can see the picture. This is the dorm, which is located in Moscow. And the distance between the university campus and the dorm is about 15 minutes walk. It's very close. Yeah, this is accommodations, typically rooms for 2 or 3 persons. It depends on the building, because we have several buildings which are located close to the university campus. Some other folks living in the dorm. And now I'm coming to my 2 last slides, actually general slides. If you want to apply for a scholarship in Russia, you can find the information on this website, educationinrussia.com, and follow this procedure, which is posted here. You can first apply, pass the first stage of selection. Basically, this is done by your internal nuclear agencies, like ABAN in Bolivia. You upload documents, and if you're chosen, you can come to Russia, get your visa, and study here in Russia. You can apply for undergraduate specialist degree is a 5.5 years long degree, which is approximately a sum of bachelor degree plus master's degree. Also postgraduate degree, which is 4 years long. All education is on site, in person, full time. Languages Russian or English, and this scholarships covers tuition. If you would like to study Russian, 1 year of studying Russian language, and this practical experiments with our resource centers. And here you can see websites. Here's MEPhI.ru, where you can find all information about educational programs on this website. It's available, and there is a general contact of our admission officers. If you have questions, you can contact them. But for you, I also posted my email here. You just can write me if you have some scientific questions about nuclear detection techniques, or some general questions about university. Just only write that you are from Bolivia and participated in this course. It will be easier for me to try to remember you and answer your questions. I think that's it for my short presentation. Thank you for your attention. If you have questions, you can also ask them. If you don't have questions, you can answer. You can ask them later. Okay, thank you again. See you in Russia. The result being tested and the picture.
Nuevamente meterlo porque ahí te va a aparecer automáticamente. Acuérdate. Más de mil. Vas a tener que dar nuevamente.
Yeah, let's do that. Aqui, tá aqui. Uhum. Uhum. Oh. Yeah. Okay.